Hi, welcome back. Our statistics class. So today we talk about regression line. So let's use the data from the last example, which is the airfare and the distance. So how do we know that which is the best line? Yes, we see this could be a multiple line. So that means some people may draw a line like this one, or some may draw a line like this one, or some may say, hey, this is also a line. Yes, they're both correct, I would say, but we need to find the best line to fit all of the data. So what determines the line of the best fit? So there's a ruler of that. So when we draw a line, so draw the vertical distance between each point and the line, there are residuals. So for example, if we choose this purple line, okay, so residual means, hey, this point, the distance to the line in here, this part is called residual distance, which means it's a perpendicular. And this one are also residuals. Okay, for example, this is the point 1. This is residual 1. And then point 2, we have another residual. We call it residual to R2. And then like say, even for a small line like this, they have a residual 3. So what determines the best fit? The best fit is the list of the residual. So the sum of all the residual is the list sum of all the residual for one line is best fit model. So the least square regression line is the line that minimizes the residuals. For example, so let's compare two lines. So we have a line in here. The green one, is that obvious? Okay, let's say this is green line. So you can tell, hey, the sum of this residual, when they add these parts together, the distance between these parts, the sum of all of these points, the sum of it, and then we compare the sum of the residual from the purple line and see which one is smaller. The smaller number means the better fit of the model is. So in this case, obvious, the purple one is a better fit. So I'm going to erase this part. Okay, so the least square regression line. So we call this line, the line that we found, the purple line, is our regression line, which is y hat equals to bx plus b sub 0. This b1 is the slope, b sub 0 is the intercept. So you should learn this from pre-calculus. You should have learned this from pre-calculus and maybe Math 1970 intermediate algebra. Okay, so y hat is the predicted value for the given value of x. B1 is the slope of the regression line. It is expected to increase and decrease on average of the y variable for 1 unit increase in x variable. So b sub 0 is the y-intercept of the regression line. It is the y value when x equals to 0. Sometimes it doesn't make sense in the context. Okay, so now let's take a look. How do we use it? So find the least square regression line for the data. Okay, so this is the data we have. It's really hard for us to find it. So, but luckily, we have GeoGebra. So, so in GeoGebra, we have this line. It's generated by GeoGebra. Look at the lower right. So you have so many like log. Let's say if you just put in data at beginning, they don't give you a line. But if you choose the regression model, in the middle lower part, you can choose, hey, linear. They will give you the best fit line. Okay, and also they will tell you that, hey, The model is y hat equals to 0.1373x plus 817636. So this is going to be our least square regression line for the data. Y equals to 0.13. It's really hard for us to calculate without the help of the computer, so try to use GeoGebra. Don't do it by yourself. Okay, give the slope of the unit and interpret it in context. So the slope is what? The slope is 0.1373. So remember, the slope means the rise over the run, right? So that means the rise is the y and 1 is x. Y is what? Y is the airfare. In our example, x is our distance. So how do we explain this? So we can explain that, hey, with addition mile, the airfare goes up about 14 cents. Okay, give the y-intercept and interpret it in the context. So the y-intercept is what? Equals to $81.76. So what is that mean? It represents the cost of a 0 miles. So remember, y-intercept is when x equals to 0. We have the y-intercept. So that means this is represent the cost of a flight 0 miles. Or we can consider this as the flat rate. So no matter how far you're going to travel, you need to pay this $81. So this could be the tax or the service fee or the agency fee, whatever. So we can say, hey, this is related. This relates with the base cost, base fee of a flight. Okay, estimate the cost of a ticket if they travel 200 miles from Baltimore. Oh, sorry. So we know that we have our regression predicted model. Y hat 0.1373x plus 81.7636. So we know that, hey, this traveled 200 miles. Distance means our x. We put in x equals to 200. And then we can find our y. Remember, this is predicting the model. May not be accurate, but that is the most likely price that we might going to get, which is, put in a calculator, we have 122 cents. $109.22. This is y hat is our predicted value, not the real value, not the observed value. This is the predicted value. Okay. So which airfare have the largest residual? What is the value of the residual? So now let's take a look. Which point is further away from the line? So you can look at my graph is not perfect. Let's go back to GeoGebra. Which one is so far away? This point, right? This one, it has the largest residual because this point stay furthest away from the line. So let's say this is how many miles? Maybe approximately 900 miles with 300. So which is, let's look at our chart. So from our chart, which one is with the distance of 900 and approximately 300, cost 300. So which is our Miami? the trip to Miami. So these have the biggest residual. So we know that, hey, Miami has the biggest, the largest residual. And then now let's do it. So the distance from Belmont to Miami is 946, right? It's given on the chart in here. The distance is 946. So what will be the predicted price? We can find out by using our regression model. Yeah. So this is x equals to 946. So y hat, remember this is the predicted value. Y hat is the predicted value equals to 0.1373 times 946 plus 81.7636. This is equals to 211.65. But in reality, which is our observed price is what? Let's go back and take a look. The observed price is $3.50, right? So what's the value of the residual? So residual equals to, in here, the observed value minus the predicted value. The observed value is what? So let me write this down. Is equals to the observed value minus the predicted one. So now we need to identify which one is the observed one. So the observed one is 350. Subtract the predicted one, which is 211.65. So the residual is $138.55. Oh, 13.5 thanks. I'm sorry. 13.5 cents. So this is the residual. Okay, next time we'll talk about the other feature of the correlation and the regression. Let me know if you have other questions.